Hi, welcome to Dynamic Math. I'm Bridget Demars. This is the first note packet. You can see that the way that these are going to be set up is all of your objectives will be in the corner. And I have all of your pages numbered. Every time I start off a math course, I always try to begin with some kind of problem-solving question so I can see where you're at with techniques if you're trying to figure something out. And the handshake formula has always been one of my favorite problem-solving problems. And so we're just going to start off by looking at this question here. There are 5 people in a room, and they shake hands as they introduce themselves to each other. How many handshakes happen? There's tons of different ways where you can try to create a situation where you're watching this happen, but usually there will be a majority of people that will just look at this and say 5 people have to shake hands. That must be 5 handshakes per person, and 5 times 5 is 25 handshakes, and it's not that simple. Sometimes I'll see people do this where they will draw the 5 people and they will draw little rainbows demonstrating who has shaken hands with who. And this is actually a really effective technique. If this was the way that we were going to do it, you would probably have the very first person introduce themselves to the other people in the room. Now, once that person has introduced themselves, they're done with their handshakes. So I can start counting them out because they will have no more handshakes to do. Then I'll go to the next person, and they're going to have to introduce themselves to who else is left in the room. And once they've done that, that person is now going to be taken out. Let's go to the third person. Third person here has 2 people to shake hands with. And once they've done that, then we can take that person and we can count them out. We have 2 people left, so I'm going to have the 2 people go ahead and shake hands with each other. It is the last one, right? Once they shake hands with who's left in the room, then we get to go ahead and count this person out. We've done all their handshakes. This person, by default, has shaken hands with everybody. Just was kind of more of a receiver and stood back, and that's great. So we have to kind of figure out how many people here have had handshakes happen. Everybody has. So that's fun. If I'm looking at how many black arrows I have, there are 4 black arrows, so I'm going to put 4 there. If I'm going to look at how many red arrows I have, it looks like I have 3. And if I have blue arrows, there are 2. And green arrows is 1. And so that's how many handshakes happen. I'm going to go ahead and add them up. 7, 8, 9, 10. Really great. 10 handshakes happened. What I'm going to do, because ultimately what I want you to gain from this is some kind of formula. A formula that describes how many handshakes happen given how many people are standing in a room. One thing I usually do, if I'm doing this task and I have people in the room with me, I actually have them stand up and shake hands and model it and count them. And it's usually kind of surprising how many handshakes happen. But since we're going to try to come up with a formula, I'm going to make a table. And my table is going to describe if I give you how many people are in the room, then I can also try to derive from that how many handshakes happen. In this case, we had 5 people in the room, and we figured out that 10 handshakes happened. If we had 4 people in the room, take a minute, maybe even draw out your 4 people, pause the video, and see if you can figure out how many handshakes happen using the same technique that we just used. If you unpause the video, then you must be ready to look and see if you've done the right thing, or something similar to what I did. So here I am. I have the first person, they go and they shake hands with everybody. That's 3 handshakes. My second person goes ahead and shakes hands with the people left in the room. That's 2 handshakes. My third person shakes hands with who's left with the room. There's 1 handshake. So if we add up how many handshakes happened, 3, 4, 5, 6. And so that is with 4 people. 4 people result in 6 handshakes. So I'm going to go ahead and add that to my table. Ultimately, if I get enough data on my table, I can start to look for patterns, and those patterns will help me come to my handshake formula, hopefully. So I guess what I'm going to do is maybe do one more modeling. So I'm going to go ahead and get rid of my pictures from before and start a new one. This time I'm going to go for how many handshakes happen if there's 6 people in the room. So I've got to draw my 6 people. I'm an artist, let me tell you. Look at this art. And I am going to start with the very first person in the room. We'll call this person Alfred. Alfred is going to go ahead and shake hands with everybody he sees, and then he's going to set himself aside because he's already shaken hands with everyone. So there goes Alfred. And then I have Linda, and Linda is going to go ahead and shake hands with everybody she sees, and she's going to leave the room. There goes Linda. Then I have Michael. So Michael's going to go ahead and he's going to shake hands with everyone that's left in the room. He's already met Alfred and Linda, and then he's going to leave. Then there's Judy. Judy is going to go ahead and shake hands with who's left in the room. And then Judy's going to leave. Last but not least, I have 2 people left in my room, and I'm going to call them Lily and Stella. And Lily and Stella are left, and so Lily meets Stella, and that's the last handshake that happens, and then they both can leave the room. Everybody has met everybody. So if I'm looking and taking stock of how many handshakes happened, the very first person had 5 handshakes. The very second person had 1, 2, 3, 4 handshakes. My third person brought in 3 handshakes. My fourth person brought in 2 handshakes. And then I had Lily and Stella. When they shook hands, they ended up having 1 handshake. 1 handshake for 2 people, right? So if I go ahead and I add up all of these, 5, 9, 10, 11, 12, 13, 14, 15 handshakes happen altogether. 6 people, 15 handshakes. You could sit here and you could model this over and over and try to fill your table full of data, but I'm going to tell you, 3 people in the room, there's going to be 3 handshakes. If there's 7 people in the room, there'll be 21 handshakes. You could find this doing whatever method you choose to use to figure out how many handshakes happened with the small number of people that I have in each room. The thing is, sometimes people would ask you for some reason or another, and especially probably now, when it might really make a huge difference how many handshakes have happened, given whatever room you're in, that there's some kind of formula that you can use to make it so you don't have to keep drawing out these pictures every single time. We have a table that is full of information. I'm going to go ahead and erase my stuff here on the side. And I want to look at my table real quick and see if I can observe some different things about the numbers that might be non-coincidental. For instance, if I look here, these increase by 3. So when I increase the number of people in the room by 1, it made my number of handshakes increase by 3. If I then again increase the number by 1, now it's 4 more people, and then 5 more people, and then you can kind of see that there's a pattern here. Every time you add a person to the room, you have the same number of handshakes as before. You add the same amount, but then you have to you have to go up by one more. So 3, 4, 5, 6, the difference keeps increasing by one every time. That's interesting. I also want to call your attention to these triangles of numbers that are happening here. For instance, on this side you have 3 and 4, and there is a way that you can manipulate these two numbers with operations. So the output is 6. Here's 4 and 5. You notice this is kind of the same triangle, just shifted down one. If you manipulate 4 and 5 in some way, your output could be 10. Whenever I'm trying to manipulate numbers, for some reason, I always go to multiplying first. If I do multiply 3 times 4, it gives me 12. If I do multiply 4 times 5, it gives me 20. Not exactly the output I was looking for, but I do notice something. Whenever I multiply these numbers and I get some kind of result, it is double what my handshake is, right? 4 times 5 is 20. 20 is double what 10 is. Or you could say the handshakes are half of my result when I take the product of those two numbers. And that is the formula. Actually, if you look here, we can shift down a little bit. 7 times 6 is 42. And if I cut that in half, 21. And that's our handshake formula. We just got to figure out a way to write it. Anytime you ever write a formula, you always should name your variables. For instance, H stands for handshakes. And I'm going to have N stand for number of people. And because I'm making a formula, I'm going to start off with H equals, because I'm trying to figure out how many handshakes happen. I'm going to pick some kind of arbitrary number here on my table and say that this is n. Okay, so I'm going to put n in here, and I know that I have to multiply n by another number. In this case, if 7 was my n, 6 would be that other number, right? Because that's how the triangle is. So if 7 is n, I have to figure out how to express 6 in relationship to 7. And 6 is 1 unit less than 7. So I can express 6 by saying n minus 1, right? If I plug in 7 here and I plug in 7 here, it will end up giving me 7 times 6, which is what I want to do. But I also need to express that I have to cut this number in half. Whatever I get when I multiply these two numbers, I have to cut it in half. So I'm going to put this over 2. 7 times 6 is 21. 42 divided by 2 is 21. And that will work. I got to figure this out one more time, or talk about this one more time. I've got it figured out. If I was going to use 8 in my handshake formula, right? So I would say 8 times 8 minus 1 over 2. 8 times 7 over 2. 8 times 7 is 56. And if I cut 56 in half, that is 28. And I want to see if that works with my table and the things I've noticed about my table. If I put 28 here at my table, and I'm looking at all of the things that kept happening, this is an increase of 7. So that really does work with the patterns we saw before. So I feel very confident that my formula is going to work. A really important thing to look at is not as much this problem and probably how many times you've asked yourself, when in a million years am I ever going to want to know how many handshakes have happened, which probably now more than ever is more realistic. How many handshakes happen when you've got something on those hands that you don't want to spread around. The problem solving techniques that we did. So one thing that we did here is we drew a picture. I drew a picture of the people. I drew a picture, and there it is. We created a table, and we even looked at data to find patterns. Another thing we did is we tested maybe I could say theories, but I'm going to just say tested different possibilities. So when you are thinking of trying to find a formula that works, you probably wouldn't come up with it the first time, maybe not even the second time. But when you're plugging things in and you're testing it out to see if it works, it's part of the problem solving techniques. The fifth one is kind of where I'm going to go outside the box here a little bit. One thing I do sometimes if I'm trying to problem solve and I'm starting to get stuck is I might talk it out with someone or explain to somebody what I'm trying to find. And usually I will come to my own realization of what it is that I need to do, and sometimes not. But talking it out happens, and it's a good part of it. And then the last one is, believe it or not, sometimes when you are problem solving, it's best to take a break from it and then come back and give yourself some time away when you're looking at something for so long and you're just like not figuring it out and not seeing it in a different light. Sometimes it's best to go on to something else and then come back and look at it again, and your brain will have a little time to reset and maybe even possibly consider it in a different way, and it might help you problem solve better.